Hello, I'm Stefan de Koning. This is the first episode on the series using the NeTEx standard to describe the exchange of networks and timetables. When you follow this hands-on tutorial, you should become proficient in the development of software in the public transport domain. Along the way, you will learn how to read and write files and get a full understanding about the subset of the concepts in NeTEx. When I entered the public transport domain, I had a bachelor's degree in computer science and had the aim to make timetables, cancellations and delays available to the public as open data. At that time, the data was only available for a proprietary journey planner and a real-time information at the bus stops. My primary focus was on what already has been standardized in the Netherlands and wanted to understand the standardization process around it. The standardization work allowed me to get in direct contact with who produced data and who was using it, while learning how it worked on the spot. Virtually all transit standards in Europe, public or proprietary, are based on transmodel, a conceptual model developed since 1989. Conceptual because it's a high-level design. Concepts such as journey, line and route exist, but which attributes or part of them is left over to the implementer. Transmodel can be considered both a vocabulary and grammar for public transport-related data exchange. The net result is that almost every nation-state and vendor created their own proprietary standard, of which none communicated across borders. While transformation of these standards allow mapping one standard into another, having a one standard to rule them all resulted into the NeTEx format. NeTEx can be considered a serialization format for a subset of transmodel concepts. The network, timetables, fares, hence the more static attributes. Next to a written standard, NeTEx also has an up-to-date XML schema. This may suggest that XML is the only way to exchange data. In the past years, it already has been shown it's not limited to XML. CSV, JSON or protocol buffers might be used as a serialization method. Semantically speaking, NeTEx remains the same model. Let's start with a bit of computer science. In an historical context, several similar concepts were exchanged in different structures. When we consider data models, some basic understanding of terminology is required to follow suit. We consider parts of a dataset denormalized when all the properties of an object or row in a database form a unique instance. A new instance is created when a single property is different. For example, a destination of a bus would be written out as Amsterdam Central Station and applied to each journey. Opposed to this, we could group all the same names into a single destination and reference to this, especially when the destination groups all the variants, for example translations and abbreviations. The representation is more compact and the change could be applied in a single place. Another example would be the timetable itself. NeTEx has multiple ways to describe the moment when a vehicle calls at the stop. NeTEx allows us to write an individual moment that a vehicle arrives and departs at its stop, but also use a single departure time with a reference to the sequence of stop and the relative time between them. The first denormalized method allows us to be more precise. It is explicit and leaves no room to wrongly computed information. It comes at a cost. It is very verbose and therefore creates large files. The implicit notation requires a computation to recreate a timetable into a human-readable format. As this sounds complex, when to choose what? We can generally say NeTEx is not complex, it is complete. We have more ways to achieve the same. Nobody would implement everything in NeTEx. That would only lead to a very complex application and guarantee to create ambiguities. Instead, a functional scope defines what data will be exchanged and which object types will be used for this. Think about the functional scope for passenger information, for fares and for accessibility. We call these subsets with constraints profiles. Still, many European countries have created their own profiles based on the full NeTEx standard. This has multiple reasons. First, a single unified profile did not exist. The European passenger information profile has been available only recently. Second, historically the country exchanged data in either a more normalized or denormalized approach. The transition towards NeTEx matches the historical concepts and the migration is merely a mapping between the internal standard and NeTEx as a serialization. Third, there are specific local needs, resulting in making more objects mandatory than the standard requires. Local needs include easier data processing, more details in accessibility, and journey accounting. A profile can also target the need for a specific computer application. Depending on its algorithm, a timetable-based journey planner would need a specific view on a published dataset. It could, for example, prefer less stops over more detailed hierarchy. It could prefer denormalized passing times over a normalized scenario. NeTEx facilitates the exchange of this information, but could in principle also be used as data structure within the application. In this series we explore how to get started from a producer and a consumer perspective. We like eating our own dog food. Before we spin up our editor of choice, we need to continue with some boring basics. As said before, NeTEx is a fairly large standard. The NeTEx XSD is a beast, and if we want to use the full potential of that beast, then currently we have some limitation. Given what element sequence, tag capitalization and correct constraints all matter, we prefer to get some assistance while taming it. Our goal is to transfer the input XML into an object that our programming language of choice understands, and preferably vice versa, so it produces valid XML from that object in reverse. This transformation is called a language binding. There are several languages which are more than capable of handling XML schemas using a binding. Some are not. We want to learn you the way working with XML is intended and be self-sufficient. In this video series we will explore Python. You could certainly use Java, and it's very likely C++ will work for you as well. C# has some nifty details. While it is possible to create a binding from a full-featured example XML file, we would strongly advise you against it and doing it the right academic way. Let's dive in. At present, Python has a very nice library for juggling with XML schemas. It's called accessdata. Installing it would be something like pip install accessdata. This will bring you the accessdata command line interface. Let's generate a Python language binding. Okay, that took a while, but maybe we can write our first NeTEx profile. Okay, we start obviously with importing NeTEx because we have just created a NeTEx package. And we need an XML serializer because we are going to write our first Hello World file, and we have a serializer configuration. In our configuration we will skip the default attributes in our output, and we will have pretty printed files because I like pretty printed things. So we open my first NeTEx file, and publication delivery is the single root element we can use, and eventually rewrite that out to the file we have just opened. It's very important when we have created NeTEx files that we are actually validating them, and we do that with XML_int. So no out means don't output anything of the input XML file. Schema is the schema towards where my NeTEx publication, the XSD, is stored, and my first NeTEx file is the location for where my just generated file is. Now what we have learned. Even with a language binding we can really create files that do not match the XSD. And it takes a pretty long time to validate XML files. And it takes a pretty long time to check a NeTEx file even if it has only 2 lines. What would then be the minimum Hello World example? We need quite some extra things. Our publication delivery has some mandatory elements. For example, the publication timestamp, and yeah, I want to write an Hello World, so I add a description, a participant, and once I write that down, I get a very nice XML interface. Every time that you see NS0 in your XML document, God kills a kitten. Let's not do that. We can change our example by adding a namespace mapping. And the namespace mapping includes our default namespace, that's the quote one, and the GML one is something that we will use later, but we are just adding it now. Once we run our code now, we can see we have a very pretty printed XML output for NeTEx. As you might notice, XML_int is still very slow, but validating what you send to other parties must be correct. What causes this wait time? In our case, our 6 lines output is not the culprit, but the compilation of 142 612 lines of XML schema is. One of the better methods to tackle this issue is to have a running process that caches the schema. We can do this in Python, obviously. We open the publication file and create an XML schema, and then validate each time that we produce a NeTEx file by just running the function validate NeTEx. As you might have noticed, we are using a very specific XSD here. It's called no constraints, and key identity constraints are used within XML schema to assure that references between objects are valid. Objects use ID in a unique manner, and the key in the key value pairs must appear only once in the key value pair list. There's more to say about it, but the performance of libxml2 at this point is underwhelming. For a quick syntax check, the no constraint version is enough. And what you can do from this point on. You could implement a service that accepts NeTEx XML files and by either a file reference or plain text content. Or implement a file notification daemon where you will use Python watchdog to check if the file has changed. And after every write, you just run the validation function. Build something that helps you development and keep the quality up and never get the nagging comment, your file does not match the XSD. We are going to support this video with the repository so you are able to check why examples work and won't. I will accept in pull request and maybe re-record this video if your pull request is much better than my examples. So, what will be happening in the next episode? We will talk about frames. We will talk about metadata and the things we cannot ignore, obviously. That is it for now. Looking forward to our next presentation.